Hey guys, welcome to the video. Today we'll be going over NAND gates or not AND gates. So if you look at the truth table over here, this is sort of what the circuit does, and basically what's happening in this truth table is this circuit is taking our two inputs A and B and it's multiplying it, and then it's taking the product of A and B and it's inverting the value. So let me show you what that means. So take for example we do this case where we have an input A of 0 and an input B of 1. So if we multiply that out, we get 1 times 0, right? Take these two values, multiply them, 1 times 0, and we get 0. But if you remember, this bar over here, that basically shows the equation, this NAND gate, this bar inverts this value. So if we take the invert of 0, we get 1. And as you can see, that's our value C here. And this will basically work for all of these values. So now that we know what this NAND gate does, let's go into how exactly this circuit works. And also, this is the schematic you'll generally see in circuits for the NAND gate. Rather than drawing out like a whole schematic, they'll usually just denote it with something like this. And you'll see this circle for any sort of NOT gate, like in the NOR gates or in the NAND gate. Yeah, you see this small circle in front of the symbol. So let's go into the circuit. So as you can see here, we have two PMOS, two PMOS transistors and two NMOS transistors. And an important thing to note is that when you put a low input on the PMOS, then it'll turn on. And when you put a high input on the PMOS, then it'll turn off. And the NMOS is it's different. It's the opposite. So if you put a high input, then this NMOS will turn off, and if you put a low input, this NMOS will turn off. So as you can see, these are our two inputs. We have input A here, input A here, input B here, and input B here, and we'll get our output C. So let's just go through the cases and I'll show you exactly how this circuit works. So let's go through, say, this case here. Alright, so input A is 1 and input B is 0, and we should expect to get a value C of 1. Alright, so remember when we put the PMOS to high, this turns off, okay? But this one turns on because it's set to low. When the PMOS is set to low, it turns on. So it acts like a closed switch, and this is an open switch. And we can do the similar analysis to the bottom. But when the NMOS transistor is set to input of high, it turns on. So this transistor will be on, but this bottom one will be off, right? Because it's set to low. And NMOS, when the gate is set to low, it turns off. So if you imagine this as a closed switch and these as open switches, current has to travel through here, through this transistor, through here, and it can't go down to the ground here because this transistor is off, right? So it acts like an open switch. There's no path for current to go to the ground, so it's forced to go out through the output here, and that's why we get a C of 1. So you can see how this circuit is able to take these two values, 1 and 0, and return a signal on the C, a high signal. Now let's just go through one more example just to show you guys that this circuit in fact is correct. Let me just clear out my screen here. Alright, now let's do this bottom configuration, right? A is set to 1, B is set to 1. So let's just write that down here. A1, A1, B1, B1, and we should expect a value of C of 0. Alright, so let's look at this. So remember when we set our PMOS to the PMOS gate to high, the transistor turns off. So this will be a closed switch. And the same thing here. So we're setting the gate to high, so this turns off. And these ones turn on, right? Because these are NMOS. So when you set these to high, unlike PMOS, these will turn on. So these will be like closed switches, we'll imagine. So now let's just analyze the circuit from here. So because these are both acting like open switches, because these transistors are off, there's no way for current to actually travel to this output, right? Like, it can't go through here. This is an open switch, right? There's no way current to travel. So by setting these two inputs to high, we've now cut off any path for current to ever reach the output. So the output is read as low. I hope you guys enjoyed the video, and that pretty much sums up everything you need to know about NAND gates.